This week, we're going to look at rates of change and linear functions. Let's say somebody took a trip from San Antonio, Texas to Orlando, Florida. They kept track of the time that they had traveled and cities that they got to along the way. Suppose that they started in San Antonio at time 0 and they had traveled a distance of 0 miles. But after 4 hours they were in Houston, they had traveled 200 miles. They were in Tallahassee after 14 hours. They had traveled 775 miles. And then they were in Orlando, Florida after 19 hours, 1,100 miles. Could we figure out the average miles per hour between any two cities along that trip? That's an example of rates of change, of average rates of change. This is very closely related to slope. Suppose that we kept track of time on the x-axis, track of the distance on the y-axis. Then at time 0, we were at distance 0. But when we got to after 4 hours, then we were up to 200 miles. Okay, so it would be at this point right here. So we're interested in finding the slope of this line. That is, the number of miles that we traveled, 200, divided by the time that we traveled for. Notice in this example, the distance that we traveled is a function of time. If we know how much time we've traveled, then this table tells us how many miles we had traveled in that much time. A linear function is a function that has the same slope between any 2 points. This function is not a linear function. If you find the rate of change between San Antonio and Houston, it's different than the rate of change between Houston and Tallahassee, for example. But a linear function are those special ones where this where the slope is always the same. F of x is a linear function if it has the form some slope, some constant slope times the x plus some intercept y.